Okay, great. So I'm going to give a talk that has a lot of JavaScript in it. Sometimes that gets a reaction like boo, you know. How many of you guys have to work with JavaScript on a regular basis? This is the case everywhere, right? And but people say, "Oh, I'm a Java developer. JavaScript's is bad language." What I'm going to try and talk about in this talk is that assumption, that mindset. It's kind of an illusion, right? Everybody has to work with JavaScript these days because it's everywhere. It's in the browser. So, and what I want to do is introduce some things too in this talk that challenge your assumptions about whether JavaScript even is or isn't part of the Java environment. So we'll talk about that. I'm going to talk about web extensions. How many of you guys have heard of web extensions? Okay, I'm going to get into what those are and how they work. And I'm also going to talk about isomorphic applications. How many people have heard of this concept? So isomorphic applications just means getting your code to run in multiple environments. So and then finally, I'm going to talk about the project I'm working on with Mozilla and what it's about and filter bubbles. And we can talk about that. And then I have some robot stuff that I work on that's just kind of fun and cool. I don't know, do you guys want... The robot stuff is like 3 minutes of interesting robot videos. Do you want it at the beginning or the end? What's that? Beginning? Okay, great. Sorry, I'm hard of hearing. Too many rock shows. Let's see here. So I was roommates in college with a guy named Dave Hansen, who's become famous for making super realistic robots. I'm going to show you some of those, and then I'll show you a current video with any Jimmy Fallon viewers. Anybody like Jimmy Fallon in here? So I'm going to show the Sophia robot on Jimmy Fallon. Then I'll show you a development video from 2014 in Hong Kong, just to show you kind of how quickly things moved along.
Do you know where you are?
Of course. I'm in New York City, and I'm on my favorite show. The Tonight Show.
Sophia, can you tell me a joke?
Sure. What cheese can never be yours?
Cheese can never be mine. I don't know.
Nacho cheese.
Yeah, that's good. Yeah, that's not. I like nacho cheese.
Nacho cheeses. Ew. I'm getting laughs. Yeah. Maybe I should host the show.
Okay.
That's a really fun thing to work on, right? There's a lot of stuff going on inside Sophia. There's about 40 motors in there that you've got to control. There are real-time message bus, message queue kind of things going on to control all that. There is voice synthesis, voice recognition. And the voice recognition, you know, prosody, emotional content analysis. There's a lot of stuff that you get to play with trying to build a system like this. It's kind of like Alexa, right? But you're then trying to extend beyond that and get it. You don't think about your face as a user interface, but you know, or your arms, or your hands, or gestures. But all of these things are very meaningful, you know, to a person. We have these very sophisticated rules we've built up about how we communicate with each other, and it's interesting to program it because you have to really become conscious of all these things. So when Dave's been doing this stuff for a long time, but their animation platform previously was more like the kind of system that, let's say you had a assembly line automation and you're trying to control an arm putting lids on applesauce, you know, going by on a conveyor belt. That was kind of like more what they were using. So in that face, there are dozens of motors controlling pulleys and, you know, that mimic the tendons and other structures in your face. So a motor like pulls a cord that pulls a net that's fused into the patented rubber that Dave developed that creates these, you know, different expressions, right? So Dave and his team were having to go in and on a timeline, just each motor basically you had a graph representing the motor position, and they had to painstakingly position each of those things. Well, in a Disney movie or like a Pixar movie, there's a way more mature set of tools for doing emotional animation. And how many of you guys have ever used Blender or Maya or any of these kinds of tools. So Blender is an amazing piece of free software that gives you a really robust set of tools for building awesome animations. And I had talked to Dave and said, you guys should be using this. We could write a binding layer between the animation tools and the motor control in the robot operating system. So has anybody ever heard of the robot operating system, ROS? So ROS does some really cool things. It is like an operating system for robotics, right? Robot operating system. So, and what does that mean? An operating system provides a layer of abstraction between your program and your peripherals. So, for instance, let's say in the early days, early word processors like a Wang word processor or an IBM word processor, Wang word processor could work on a Wang printer, and in fact, maybe just even a specific Wang printer. So literally the word processor in its code had the control codes for this specific printer. You couldn't take an IBM printer and put it on your Wang word processor or vice versa because they were written specifically to work with each other. And when operating systems got more mature, they provided an abstraction layer. So you had, this idea of a document that needed to be printed. Word or your word processor manipulates a document and it says, hey, operating system, print this for me. And the operating system takes care of translating that abstract idea of a document into the control codes to control the printer. So ROS does this for robotics concepts. So for instance, there's two major kinds of motors, a servo motor and a stepper motor. A servo motor has a single control line usually, and it uses a timing of the pulses on the control line to set the position, the rotational position of the motor. A stepper motor has multiple control lines and manipulates this by activating the lines in series, also sets the rotation of the motor. If you're writing a program, you don't really care how that all works. You just say, I have a rotational joint. I want it to be at 45 degrees. And then the ROS takes care of the translation between that abstract idea of a rotating motor and the physical reality of manipulating some specific piece of hardware. So I wrote a binding layer that would take the animation rig in Blender and then connect it to the ROS abstract concepts of motors so that then it could drive the actual motors in Sophia's head. So I'll have a small contracting company in Dallas, kind of size business. Maybe any of you guys could start. We have 4 employees, but we do all kinds of different things. Most of what we do to make the rent is to build ERP systems, usually on Apache Open for Business, and usually with a modern JavaScript front end. So I spend a lot of time writing Java and writing JavaScript. And but I did have an interesting piece of work come in that Mozilla wanted me to help them do something with filter bubbles, which is kind of the whole fake news kind of the just modern media, and trying to build tools to help users understand what's going on in modern media, and to demonstrate the new WebExtensions API. So what are WebExtensions? WebExtensions are a new API that was a collaboration originally between Mozilla and Google Chrome to allow you to write plugins for the browser using JavaScript to write the code and HTML to build your user interfaces. So instead of C++ and XPCOM and kind of all these like the internal implementation specific details of a browser, you have this very high level programming environment that's pretty much like what you're used to already building normal web pages with JavaScript. And it lets you add new buttons to the toolbar in the browser, and this is just an HTML page. And then you can do all kinds of stuff that you can't do from a normal web page. It lets you, you can monitor user activity. You can watch what all the tabs in the browser, what pages they're on. You can tell when they change pages. You can get a callback when somebody switches pages. You can look at the content you can look at the DOM of every window that's open in the browser. You can see the history of the browser. You can see the bookmarks. You can manipulate the bookmarks. You can create bookmarks. It basically lets you control the browser, and way more control, way more access than you have from within a page context. And it currently is, I'm not going to say it's 100% portable, right? It's not exactly like you write the same piece of JavaScript exactly and it will run across Firefox, Chrome, Opera, and Edge, but it is like 95, 98% there. And there are more and more libraries. There's already a number of libraries that create polyfills, right, which is an adapter class essentially that mostly smooth out any of the remaining differences. So already with a few libraries, you can reliably write a single JavaScript HTML piece of code and plug it into all four of these browsers, write an add-on to any of these browsers. And that's a really powerful concept. And so the structure of one of these things looks basically like this. You have a manifest file that sets up the different components. You typically then have a couple of different UI elements. So you'd have that pop-up. You have a pop-up HTML and a pop-up JS. So just like building a web page. You also, I don't have it here, but you can also create options pages. So just like if you've used any of your plugins and you go to settings and it brings you to a separate page where you can control the settings for that plugin, that it lets you do that kind of stuff. But then you also have a background context script that when the browser kicks off, it'll run your background script, and you can start processes then that run continuously in the background all the time. The pop-up, basically every time you pop that pop-up and then let it close, it's as if you've reloaded the page. So the state resets every time, but the state of the background script, it's there all the time. And you also then have content scripts, and what the content scripts do is that when any page is opened in the browser, it lets you inject your own JavaScript into the JavaScript environment of that page, and you can add additional listeners. You can manipulate the document. So you could be like you could put a content script in there that goes, oh, am I in the Google web page context? Okay, I'm going to make the search field blue, and anytime you went to Google on that machine and opened it, the search field would be blue. So you can do anything, right? It lets you add JavaScript to any page that's your JavaScript. So with that in mind, let's talk about isomorphic applications a little bit. So what could you do with one of these web extensions, right? Well, let's say you've got your Java, enterprise tool, they're your company, and you want to have something easily that when a sales lead comes in, all the time one of your sales guys can just hit a button and here's your form to fill in a new sales lead. Boom, it goes up to your Java server. Or let's say you have two legacy applications, right? How many times have you had this, and that you have to open something in some page in a legacy application, somebody's actually sitting there in another tab and keying it in? Well, you could make an extension that can see, oh, I see you've got the old order application open and you're trying to enter in a new order, and it could just reach in, pull the data out of the one and paste it into the other form, so that then the user could look at it and go, that's right, hit submit, instead of having to rekey everything. Well, lots of opportunity, right? Anytime you want to all of a sudden reach into two pages or anything like that, you can do that. So how many of you have had to write JavaScript form validation code? Right? So one of the things I want to challenge you to think about as I go through this talk is how much could you reuse that exact same validation logic inside your Java application? There's more and more tools to do this kind of thing. One of the classics is Rhino. That's been around a long time. But in Java, in the VM, now standard in the VM, there's a tool called Nashorn. Anybody use Nashorn? So Nashorn is a much more high-performance JavaScript environment that's built into your JVM all the time. I'm not talking to that. But there's also things like ClojureScript, which if you're writing Clojure, you can compile Clojure into JavaScript with ClojureScript. But there's also JSuite, which JSuite, you can write standard Java, and it will compile your Java into JavaScript that you can then put into your browser pages. So what about Nashorn? Nashorn, like I said, it's the JDK's JavaScript solution, shipped standard in the JDK, in the Java VM. It's there all the time. And Oracle is putting serious effort into making it high performance. In Java 7, you had Invoke Dynamic. There's improvements going in every Java release to improve the performance of Nashorn. I won't tell you that it's at parity with Node.js, but the gap is closing. In many situations, it's going to perform, close to Node.js. But the big difference with it is you're in the Java VM. So you have access to facilities in the Java VM that just don't exist in Node.js, right? Node.js doesn't have threads. Right? There are no threads for Node.js. So anything you do with sending data back and forth between workers, you have to send essentially message objects and pass data by value. But let's say you have something like the disruptor ring buffer, right, which is a super high performance Java ring buffer structure. It's used like some stock trading applications use it. If you've got an 8 gigabyte in-memory data structure that you're sharing between a bunch of threads, that the threads are simultaneously manipulating that, you can't go handing an 8 gig object between workers, right? So you can do things with JavaScript in the Java VM that you just can't even do in Node.js, right? It's just not even possible. So a apples to apples performance comparison is hard to make because the facilities are simply not there. And how easy is it to get going? So these two lines kind of show you a super simple example of doing a little JavaScript. You can ask for a new script engine from the script engine manager. You ask for it by name, Nashorn. And then here you go engine eval, and you can put any JavaScript you want in there, and it'll run it. It will convert it to Java bytecode and execute it. But you can not only, spit something to standard out. If you instantiate an object in JavaScript here and return that, you're going to get back an object handle in Java that you can call methods on. And you can even pass Java objects into and have that JavaScript object call methods on your Java object, and it all works seamlessly, right? It's all just more objects in the Java VM. So that's one of the things I want you guys to think about is don't think about it as like there's JavaScript world and Java world. Java is a human language. The Java VM does not run Java source code, right? It runs Java bytecode. Well, Nashorn compiles JavaScript into Java bytecode. So JavaScript with Nashorn is just another way to produce Java bytecode. So if you already have validation logic, if you already have value in your existing JavaScript that you've had to write for web applications, before you rewrite it in Java, take a step back and go like, can we just use that? Do we have to rewrite that? And really think about that, right? Because if you get in the position of that you're not only doing your validation logic, let's say in your web application, but now you're talking about doing an iOS native app, and you're talking about doing an Android native app. That you're going to have to keep your Objective-C version of that validation logic, your Java version of that validation logic, your JavaScript version of that validation logic. That's all engineering hours, and those are all opportunities for failure, right? You can have drift between your versions, and that's how you get serious bugs in your platform. So you want to, don't repeat yourself, single source of truth. Can you reuse that code? And that's what isomorphic applications are about. It's ECMAScript 5. I think there's some ECMAScript 6 coming, but you can, you can run Express with Babel. Like you can use Webpack and Babel and produce with the transpiler. That will work on Nashorn. So you can use ECMAScript 6 constructs, they're just transpiled, so there's some performance considerations. But like I said, Nashorn is definitely under active development. Oracle definitely gets it that JavaScript in Java is a big deal, and they are pursuing that. Because, the reality is, for Java in the browser, applets are gone, right? Nobody's even thinking about it. I mean, and now that they're officially gone, nobody was really that happy about using applets for a while now. So the web is just getting to be a bigger and bigger deal. And JavaScript is everywhere, with tools like PhoneGap, Apache Cordova. Anybody ever play with that? You can build a simple web application and package it for the web store. You can put it into the Apple Store, put it in the Android store. So there's these powerful platforms that are emerging to let you move your code between all kinds of different environments. And you can get Node.js kind of style work with, yeah. Yes. Yes. So you should be able to call any method on any Java object from JavaScript using Nashorn. So anything you could write in Java, I believe, and I believe you should be able to, you can do things like manipulate threads from JavaScript in using Nashorn. Like, you know, if you have a handle to those objects, you can call methods on Java objects. So anything you can do via calling methods on Java objects. You may have to do some casting. You may have to go, depending on, like, if you try to do something really low level, I don't have a pat answer in terms of, you know, will it be easy? But you should be, anything you can do in Java, you should be able to do in JavaScript. There may be some interesting things when it comes to getting, if you have, like, you know, a method that you're using casting, you know, that the type detection plays a big role in it, it may get a little complicated. But so you may have to do something like write an adapter class in Java that, like, gives JavaScript a little help in hand, just to understand the typing system. So, and, you know, because there's so much happening with JavaScript, there is a lot of evolution happening in the JavaScript space with things, very sophisticated concepts that are hot in the Java space, right? The same kind of ideas. Like immutable with JavaScript, callback-oriented programming in JavaScript is very, very sophisticated. So, like, our Java programmers are kind of just now discovering lambdas and how to deal with them. Well, JavaScript has been thinking that way for a long time. And, you know, like, a big reason that asynchronous I/O is in Java, right? Everybody kind of remembers the history, is Node.js came out of nowhere all of a sudden, and for huge numbers of simultaneous sessions, Node.js was just handing Java its butt, you know, because it wasn't that Node.js produces way faster code, right? It's a way different strategy, because if you have 10,000 simultaneous sessions on the old servlet structure, you have 10,000 threads. But on Node.js, you have 10,000 callbacks sitting in an array with a thread iterating over those and seeing if data is ready, and then just going, here's some data, here's some data, here's some data. So that getting rid of that overhead of all those threads that's why they did async I/O, you know. And now Java has very good performance. So now that people are using those kinds of techniques that mostly came from the JavaScript space, in the Java VM, you can get back to parity in performance. So there's a lot of stuff going on around callback-oriented programming in JavaScript that you may find it's actually easier to write it in JavaScript, or that there's more mature tools available in JavaScript. Because things like, you know, everybody remembers when you first were doing $get, and you had your success callback. Like, let's say you're trying to call a series of REST services in order, and you're having to nest them one inside the other, right? And you get these kind of crazy flying V's in your code. Well, people in JavaScript land got sick of that, and that's where the then operator came from, and things that you could thenify, where you're saying, I want to call this, and then when that's done, I want this function to be called, and then I want this function to be called. And you can have very clean code for doing these kinds of nested callback-oriented structures, and it's a different way of thinking. So spending some time in the JavaScript space with these libraries will really up your game for using lambdas in Java, because it's conceptual, right? It's not about the language, it's a concept, just like for loops or ifs, you know, any programming concept. It's really about the concepts, because it's easy to learn. If you understand a concept, it's easy to go to a new language and understand and learn that concept in a new language. If you don't understand the concept, then that's what's hard to learn. So I'm doing some work with React. How many people are working with React or Redux? So this is an example of some really cool concepts that can be applied in the Java space, but it's about the conceptual framework. So in a React application, state is immutable. you have action objects that run through things called reducers that atomically manipulate the state. And because you don't have threads in JavaScript, it's really an atomic situation that you have a very predictable state transition. I'm going to talk about that in a second slide. This is just to give you an example. How many people have written anything where you do, callback driven, like swing, swing programmers, or just in JavaScript, you go button on click and you write a function. And in that function right there, maybe you do a jQuery get. Well, if you have a lot of this kind of stuff going on, you can have a pretty complicated interactions between all the timing of how these events happen, right? Because you think you're going to be able to do that jQuery get and it's going to come back in a particular order, but if you're assuming that's always going to happen with certain timing, that can get real complicated, and debugging that, understanding what's going on, can get very complicated. So what happens with Redux and in React is when you trigger an event, initially you never do anything right then, other than you create an object that represents a request to do something, and you essentially put it on a queue that's going to get processed later outside of your code in a deterministic way. And then the thing that actually processes that, this is an action event in React Redux land, and then later the action event processor, you see that you're going to do this action, and you take the state, you make a copy of the state, and you return a modified copy. So this is side effects free, right? Because you never directly manipulate a state. You always copy the state and return a new modified copy. So that has some interesting side effects, because you have those action events end up being like a player piano tape. You could think of it like it's a mechanical tape controlling your program. You have an action, 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 and they happen in some order, and it's very easy. You can audit, right, this stream of actions, because it's actually just, you could think of it as an array of objects representing actions that your program needs to take. And they cause a series of state transitions. And because state is always modified as a copy, right? The transition is very easy to understand. So let's say you got your to-do list, right? You start out empty to-do list, add a to-do, got now a state with one to-do, add a to-do, two to-dos, remove a to-do, back to one, right? This approach lets you do some very interesting things in terms of testing, in terms of debugging. So let's say you put a feature toggle in your app where if you have let's say you have users that are having problems with some facility, you could turn on a feature toggle that you're going to record the action, the series of actions, and when the error occurs, you're going to push that series of action objects up to the server, so that then you can pull that series of action objects down to your development environment. If you replay them, if you write it correctly, if you follow the rules, you can play back the user's series of action objects, and you'll get the exact same state, right? It's deterministic. Which is fun, that when things get complicated, you start going, can it really still be deterministic? If you have a computer program and it's deterministic, no matter how complicated it is, you can replay it, and mechanically you're going to get the same state. So this lets you do some pretty interesting things. Like, let's say let's take this. Let's say you want to test, let's say it takes you hours of interactions to get to this state, and then this is where your errors start happening. Well, you could serialize this state. You can then unpack that serialized state and start playing a series of actions against it, and you're again going to just be able to move forward from there. So it lets you snapshot time travel. If you want to do undo, right, all you have to do to implement undo is you just snap the application state back to the previous state, and because the entire application state is in a single state object, that your whole app will just snap back into place. If you say undo that delete, well, there's two to-do objects again. So that's kind of what I covered here, but I think it's easier with the illustration. And for testing, again, you can have your mock state that in your test environment, to test your application, you can just restore this complicated user state that represents a long-term interaction and start playing it back from there, instead of having to always replay all the way from the beginning, kind of like in Selenium. So Filter Bubbler is a program, is a web extension that I'm implementing It's sponsored by Mozilla. I'm working with them. And it is to let you, is first of all to demonstrate the WebExtensions API, but then it's also to let you analyze your web browsing habits in kind of the same way that big guys like Facebook and Google are analyzing your web browsing habits right now. And it's to let you visualize your filter bubble. So what's a filter bubble? A filter bubble is really another word for cognitive bias, right? How many people have heard this term, cognitive bias? Like, cognitive bias, an example would be, I'm a Java guy. I'm supposed to not like JavaScript or view it as this other thing, right? It's a cognitive bias. It's a set of assumptions that we see the world through. So sometimes those assumptions can be accurate, like you shouldn't jump off a cliff. Sometimes they could just be things you've picked up along the way and that's you believe are true. Maybe they're true, maybe they're not. So this has always been typical, right? We surround ourselves with people that we like. We read magazines and newspapers about things that we like. If we like bicycling, we read bicycling magazines. We know a lot about bicycling. We may not know about knitting. So that's normal. But now that search engines and social networks play such a dominant role in our lives, these organizations are using very sophisticated tools to monitor our behavior and take advantage of our cognitive biases to control our browsing habits. So, at Facebook, for instance, they're using the most sophisticated techniques available, deep learning, big data, all this. I mean, they invented a lot of the big data stuff, right? Why'd they do that? Well, to analyze their users' behavior and to send you, theoretically, the posts that you're going to like the most, right? So that may be one of the key performance indicators that they're using is how much you press like, but obviously they have some other things on their agenda. They want to keep you on the system. They want your time on Facebook to last a long time so they can serve you lots of ads. They want you to click on ads. So if they notice that people with browsing habits like yours click on certain kinds of ads, they're going to try to look in your friends and look for posts that look similar to the kinds of posts that make people like you click on ads, right? And we don't have those tools ourselves to understand our own browsing habits, and we can't even see these things, right? So that in some cases, these organizations understand our behavior better than we understand ourselves, our own behavior, because they have a very sophisticated knowledge. So the goal of Filter Bubbler is to try to give us some tools to do analysis on our own behavior. So what does Filter Bubbler do? It's really, in essence, similar to a spam filter, right? Everybody uses a spam filter, right? Who uses a spam filter in this room? Everybody, right? You ever think about what a spam filter does? A spam filter, you have handed a program that uses statistical analysis the authority to decide whether a message even reaches you, right? If it decides statistically that message matches spam, it never makes it to your inbox. That's an extremely powerful idea. And the accuracy is really impressive, right? Spam filtering, people 99.9998% probably accurate. And if it wasn't that accurate, people wouldn't tolerate it. But what's interesting about spam filters is they don't care that it's spam, right? It's purely a statistical analysis, like a simple Bayesian analysis. Mostly you're taking your messages, say, breaking them up into groups of 5 words, and you're doing a statistical analysis of what 5-word groups are present in what groups of messages. So it doesn't care what the patterns are that you're trying to match, and nor does it have to be one kind of pattern, one bucket of patterns. You can, for instance, I heard something that kind of blew me away, which is that the way that they evaluate SAT essays now is they use Bayesian analysis. So they take and they make a corpora of these are well-written essays, these are poorly written essays, and then they just feed essays into this. And just like a spam filter, it's got better than human accuracy. Gets 99.998% accuracy of this is a dumb illiterate essay or this is a well-written smart essay. Because bad grammar, for instance, it's a statistical profile. Certain words are used in series that they shouldn't be, right? That's bad grammar. So because you can do this with anything, what Filter Bubbler does is it lets you create a series of text corpora, which is basically your labeling URLs. So let's say, real simple one, you're just going to go, this page has awesome stuff on it. This page has stupid stuff on it. And you're going to build up a list of two lists of URLs. System is going to read the text of those pages and build up a statistical profile of awesomeness and stupidness. And so then you can, the whole system is pluggable. So the source is pluggable, the classifier is pluggable, and then the output of the classification is pluggable. So a simple version might look at the page you're currently looking at, pass it through the classifier, have it compare it to the two corpora, and then make the classification show up in the drop-down menu and say this page is awesome or this page is stupid. But you could do other stuff, right? You could, oops, that's not my keyboard. You could have it that my source is the last year of my browsing history, and my sync is a new folder I'm going to create in my bookmarks. So I could take my entire last year of browsing history, take each content of each page, compare it for awesomeness or stupidness, and in a new folder have two folders under it, awesome and stupid, and my personal browsing history will be automatically separated into awesome and stupid. Think about what that would take you to do that yourself, to go through and evaluate your own year of history, browsing history, to look for patterns in it like that. And these classifications are also pluggable, and what we're working on initially is we're going to write a Java server, JavaScript server as well, but I'm even doing a WordPress plugin. So anybody with WordPress can set up their own little private classification server so that they and their friends can work together to make their own classifications of content and share those classifications and build them up as a group. So you could, beyond like this simple example, let's say you could take the New York Times, like last 5 years of New York Times stories, and separate them by department. So politics, arts, sports. And so then if you want to extract from the last year of your browsing history all the stuff that looked like you were looking at a sports page, you could again go through it and it would drop it into a folder, and you could go look in the sports folder and you'd see your pages that you visited that look like they're about sports. So that's basically the idea. We can do some QA, and I'm going to put these up so you can write down URLs if you want. So that's basically my talk, and I'm happy to answer any questions. Yeah, so absolutely, and you can. Absolutely, you can do that. So with React and Redux, they have a completely headless mode for server-side rendering, and so like if you want to preload a cache with renderings of all your product pages, so that when somebody requests a product on your Java-based website, that you're sending the HTML as it would be rendered in their browser using the same templates on your server in Java to generate them. Yeah, you can definitely do that. And with Redux, for instance, you can also just completely not render the HTML and use, like if you just want to use the reducer logic and the action stream, you can totally do that there, where you just are pushing into the state and you just don't attach the view objects to it. Like that, you can also do that. But no, yes, definitely. And you can do that not just with React, but with several platforms like Vue.js also will support that. Anybody else? Yeah.
So for Node.js, you have a lot of packages you can depend on, but for the Nashorn,
You can use NPM. You can. Oh, sorry again. For Node.js, you have the NPM universe of languages. You can run NPM using Nashorn, and you can actually run your Nashorn is pretty much at this point where it's at API parity with Node.js, so there may be some performance differences, but you can basically run the JavaScript libraries you can run in Node.js, you can run in Nashorn. So you can just use NPM, same tools that you're already used to using to build your applications that you run with Nashorn. If you do it through the script manager, it tends to reconstruct the Nashorn environment every time you ask for a new instance. You don't have to do it that way. You can instantiate a Nashorn JIT compiling interpreter, and you can keep it in its state around. So you don't have to have that behavior. It's not a one-liner. Yeah. Sure. Like, so prosody is like the sing-songiness of talking. When you go, really? Caldi is an interesting Java environment for doing some of that stuff. It's a voice recognition environment that can actually give you some tonal and inflection data from your speaker. Kaldi. Yes. Yeah.
They extract a lot of context. I mean, is that something that would be pluggable into this?
The classify, as far as the classifier framework is concerned, the filter bubbler just is interested if you go, hey, classifier, here's some text. What label do you think it is? So that it's purposefully very generic, right? So then if you want to use a word2vec kind of implementation, or even like what's the Google frame? TensorFlow. Like if you wanted to have, it doesn't even have to be JavaScript. It just has to result in the JavaScript environment getting a label back. I've read about Word2Vec, and I tried playing with it a little bit, and actually there's some really cool stuff that dice.com open sourced for Solar, the Java-based search engine, to do Word2Vec so that if you do stuff like if you search for data scientist, you'll get back Java jobs, because there's a Word2Vec association. That Java and data scientists is often have a relationship to each other. Really cool. There are iOS and Android implementations, and there's also a native web implementation, but it's kind of the same idea as SWT on Eclipse, which is that you write a program in JavaScript, it is instantiating native UI peers, and then instead of Swing rewrote all the UI peers in Java, but in SWT, which is what Eclipse is written in, it actually uses the native UI peers from the operating system. So React Native is this kind of same idea, but for building UIs with JavaScript. So you could, I don't know if, like I said, that's an interesting question. I'll look into that and put something up on my website. But you should be able to do if somebody should be doing that, that would be a cool idea, is to do a React Native port for Java, so that you could take your React Native application that runs on iOS and on Android, and you could just run it on the Java VM, and it would be a desktop Java VM application. That would be cool. So in theory, possible. Like I said, I don't know. That seems like the kind of thing somebody somewhere would have been like, I'm bored, I'm going to try this, so I'm going to look. Anybody else? All right. Well, I guess I'll hand it back to our talented announcer and host, Bruno Zola.
Okay, just let me, yeah. So, thanks, Ian. That was great. Since we have, that's a new thing in the tour here. We haven't talked about. Ian give his Java and JavaScript talk, but we do have here with us a good friend of ours from Oracle.